I'm a money getter, cause I'm a money getter. Cause I'm a money getter, cause I'm a money getter. Pumping like G-boxing. Cause I'm a money getter, cause I'm a money getter.
All right. What's up, everybody? I'm about to get started. I'm just testing my stream, making sure audio was coming through okay and y'all can see everything. But yeah, for the most part, I'll probably be silent as I work through some of these challenges. I'm gonna get kicked off with this with Ethernaut, so yeah, there'll be periods of time where I'm silent, but feel free to throw some stuff in the chat and say what's up. All right, what's going on? Actually, okay, yeah, just to make sure y'all can see everything I'm seeing. Okay, well, I hope y'all can hear me. If not, then I'll fix it later. But for the most part, if you can't hear me, you'll at least get to see the challenges. And if you uh, can hear me, then that's cool. And testing audio. It looks like audio's working. Okay. Okay. All right. I can unpin this now. And no, don't type that. All right, so let's get it started. So I think for today's session, we're gonna go through levels 1, or sorry, level 0 and level 1 for Ethernaut. A little bit of background: I've done a few of these challenges before, but it wasn't like seriously. I kind of just was looking online and trying to replicate stuff and just copying other people's code and trying to figure it out. But I think for the purposes of this study session, I'm going to be um, yeah, doing a lot of deep dives. So it'll be, some of it will be long and boring, some of it will not be, but yeah, I'm about to go ahead and get started. All right, so for those of you who don't know, Ethernaut is a CTF challenge for Solidity smart contract hacking. So it's a great way to learn how to hack and how to learn Solidity. So I'll be doing that, but I'll also be doing it with Hardhat, which is a framework for Solidity development. Yeah. So it's a framework for Solidity development, and I'll throw this in the chat. And then let me also throw Ethernaut into the chat. All right, let's get started. All right, so set up a MetaMask. I already have a MetaMask account. Console. All right, let's open the console. Okay, good. I have a test account, so I'll be using this. I'll probably end up sharing my private key for this at some point, but this is just a test account. So if you try to steal this Ethereum, then you're not gonna have much money. It's just test money, testnet account. All right. Okay, let's address. Yep. Let's Folio. We're on the right network. Yeah. Okay, I want to state your player's address. Important during the game, you can always see our player addresses under the following command. All right, let's enter player. All right, that's me. It's my testnet account right here, so that's the same. All right. I'll either balance by typing get player or get balance. I think we're doing it. Wait. All right, so that's my balance. Hey, what's up, Robert? What's up? What's up? So yeah, I just kicked it off. I'm going to be starting from scratch on Ethernaut and just learning, doing a lot of Solidity learning. So um, feel free if you want to help me. If you see something I'm doing wrong, just throw in the chat like, "Hey, you probably should do this, do that." And if not, then feel free to study something else that you're studying, and then we can chat later on. But yeah, thanks for joining in. All right, then API. So for any beginners, the ABI is just a way to interact with a contract. So I come from a Solana background, and they call it IDL, and it basically contains a lot of information about like the functions you want to call in a contract. Just gives you information about the contract details or the program's details. So in here we get the owner using Chrome. Okay, that should be good. Get test ether. I have that. Getting a level instance. So for each of these challenges, and I haven't done all of this yet, so I'll be learning with everybody else. But for each of these challenges, you just get a new instance, and it allows you to get kind of create a new game for you to practice and play around with. Essentially, for like any of my Web 2 folks, it's like a VM where you get to just practice and learn pen testing, but on chain. All right. Have the contract, complete the level. All right, so we have a few things you get to learn about the contract, and this is just the intro part. I'm going to be switching to Hardhat after this. No contract set, go level and click it. Yeah. So I'm going to be just playing around with these commands just to get familiar with Ethernaut. And then after we complete this level, we'll move on to the next one. All right, so let's get a new instance. And in a later time, like if anyone wants to go over how do you get testnet ETH, I can go over that. But for the purpose of this video, we're jumping right into study sesh. All right, so all right. Also, my study method is to use the Pomodoro technique. So I'll be kind of clicking this on, and I'll probably be a little quiet during my study sessions. All right. You will find what you need in info 1. So I'm assuming there's a bunch of functions. Look at this ABI. We got info 1. All right, so I'm going to call this one. Info 1. What's in here? Parameter. All right, let's try info 2. I'm going to pass in hello. The property info num holds the number. The next info method. And right, no input. It gives me output. All right. Words. Probably info num holds the number of the next info method to call. So it's holding number 42. The next info method to call. So really, we're just learning how to interact with the ABI. And so another part of my study process is I just take notes along the way. It's a great way to recap what you've learned and what you're going through. So all right, got that. Wait, contracts info 42. method name is the name of the next method. All right. Method name. All right, let's use this. If you know the password submitted to authenticate. Well, I don't know the password, so let's see if we can find it. Password. Name. Okay, that's the password. That's our flag. All right, let's call contract dot authenticate and let's pass in our flag we just got. It probably takes it as this. All right. Let's see if we hit this challenge. And I guess for starters, I'll probably be using Sepolia the whole time. I need to learn how to do this all locally, but I want to simulate like a real experience of trying to hack a smart contract. So part of it is because this is the only way I think I know how to do it, and the other part is that yeah, I think it's just best to simulate a real environment. But in some later lessons, I'll probably be looking into like how to actually simulate an environment locally and then spin up the contracts this way. It's taken insanely long. Okay, let's see. That finally worked. All right, let's just test it out. I don't know what's going on. Submitted it. I don't think the transaction has went through yet. Let's try to submit. This is taking forever. I might need to learn how to do this all locally. Okay, looks like we're good. So when you see this, that means you completed a challenge. So we're good to go into the next. Just to recap, all we really learned how to do in this last in this level was how to interact with smart contract ABI. You pretty much learn, you know, function definitions. How do you call them? How do you pass in parameters? The whole nine. Cool. Country. I actually never took a look at the contract, but Okay. Let's go to the next level. All right, so this is where we'll honestly jump into Hardhat. So, like I said earlier, Hardhat is a framework for building Solidity smart contracts. So what I'm gonna do is kind of go from scratch of, setting up a Hardhat project. Let me first do this on GitHub and just create a new one. Uh, yeah. Mm, all right. Goodness. And I'll also post this in the chat so that for the future, if anyone's ever watching this video, you can kind of look at all my solutions, how I figure it out. Won't I? Okay. Why that's still there. Yep. I think this is how you start up your hard hat, but let me make sure I'm using the right. Um, so I didn't go through setting up Node.js, but if you have not jumped into this stuff yet, I'll go ahead and just throw this resource. Yeah, just look up how to download Node.js. This is how I'm able to use Hardhat. So I think it's npx Hardhat. Yes, that's it. Yep. Yep. We're getting all of our dependencies. Okay. All right, we should have our updated repo here. And I'm gonna just put a quick message. Um, for those new, or even if you've been doing this for a bit, I use a few extensions. I think I used the Solidity's extension. The Solidity Visual Developer is pretty cool too. And then I think this Contract Flattener, Solidity Language and Themes. So those are the main ones I'll be using. Oh, and then there's also an extension for any Hardhat stuff you're working with. Okay. Howdy, howdy. What's up, Port? I'm just going through these Ethernaut challenges. Yeah, so if I'm quiet, it's just because I'm walking through these things, but I'll check the chat periodically. We got so a few things here. After learning a little bit about Solidity from Patrick, shout out to him. His content is pretty dope. He has thanks. He has a GitHub repo full of all his stuff, and so I like to take some of his download scripts. So yeah, go watch this course if you're jumping into Solidity. I don't think I only finished like half of it. But yeah, his content is dope for this. Okay, I think it was this one. Boop. I take all of these. So yeah, basically all the stuff I'm getting in is just helpers. It'll allow me to help. It'll allow me to interact with some smart contracts. Oh no, what happened? Food dev. All right. Let's see if that works. It doesn't. Okay, let me try. Let me just try his script. Let's see. All right, so we're good with that. Ethernaut. I'm gonna just get some stuff set up here. Another thing, I also like to use any of his configs he has. Nope, that one. I think I'm gonna use only like 2 of these. I don't need coverage. Don't think I need deploy that either. I think these are the ones I need. Got everything installed. Yep, I'm good. All right, so another thing is, in order to interact, so I'm like basically I'm not going to be using Remix. I'm just going to be doing this all with Hardhat. So I need some tools to interact on chain. And we need a .env file, which is going to contain, um, it's basically going to contain my private key and my Sepolia RPC URL. You're going to insert yours here. Do not insert my stuff. Okay. I probably will end up leaking this at some point. Honestly, it's not even important because it's a test wallet, so it won't really matter, but I'm gonna try not to show it. Especially not my RPC URL, because this is what I get from Alchemy. Oh, let me actually drop that in here. All right, yeah, just yeah, follow this tutorial. And it doesn't have to be on Polygon, but whatever chain you want to work on, you could use this tutorial. All right. So I'm gonna switch my screen up. Let's go here. Actually, no. Makes you feel like I'm not here, but I'm just gonna go blank for a little bit, and I'll go to the screen. Yeah, I'm gonna go blank for a little bit and put in some details that I shouldn't share. So let me grab some stuff real quick. Let me make sure y'all can't see that. All right, yeah, y'all can't see it. All right, so basically what I'm doing is I'm going to Alchemy, go to Alchemy, register, and just go ahead and get an RPC URL link for Sepolia or whatever chain you want to do this on. Personally, I don't want to use Gorilla because they've started monetizing those testnet tokens, and I think it's pretty slow now. So I don't even mess with Gorilla anymore. But yeah. So right now I'm just going to Alchemy, getting my key. URL link. And then I'm also getting my private key for my MetaMask wallet. Private key. All right, that is my MetaMask. Okay. I feel like MetaMask is slow today. Let me see my keys. I'm having mad issues right now. Okay, I'm gonna have to go to. I think I'm gonna have to go to an old project and grab my MetaMask private key because MetaMask is being very slow right now. Right. Okay. Hmm. Yeah, I don't know what's going on. So let me open up an old project and try to get this key real quick. Here's my private key. All right. All right, let me just make sure MetaMask won't show my keys when I get back. Because it's buggy. Okay, I think I can go back to sharing my screen. All right, so I'm back to. All right, I'm back to this file. Um, Basically, what this is doing is I'm able to take in my private key and my RPC URL link from this .env file. And if you are doing this challenge along with me, whenever you go to uh, whenever you're uploading to GitHub, make sure you have .env in your git ignore so that you don't share your private keys publicly. That's a huge security issue already. If you are sharing your private keys with the world, you can consider all your money gone. So let's come here. All right. Let me also make sure I have the right things pasted in. Okay, that's what I was missing. All right, so now this next part, I have to have my networks ready. So all this is doing is using my RPC URL link to be able to connect to deploy the network. And then I have my private key, so that's going to allow me to sign for transactions. And then this thing, just the gas price and gas. These are just some of the limits I set for whenever I'm running my test. So this setup should work. Yeah, I think we should be good. Okay. So now you have everything configured. We should be ready to go ahead and start working back into our challenges. So our contracts, this is just what Hardhat gives us initially. What are you talking about? Hmm. Let me just make sure this works. Hold on. Where's the file dependencies be installed? Okay. Please run. All right, so I'm having some issues with my configs. Let's see what this looks like. And I might have to delete this log file and use npm. So these are the things you typically won't see on a lot of YouTube videos of people debugging stuff. So this is good for anyone who's kind of like jumping in and seeing how do you even get stuff set up, how do you debug, all that good stuff. All right, now let's try npm hardhat compile. px hardhat compile. Okay. Q16. All right. If you heard that, that was my Pomodoro timer. I'm skipping. I want to keep going. No breaks right now. Use both. Work greasing. Okay, so make sure you only use one. I guess I'll use chai matchers. I don't really need waffle. All right, so we are able to successfully compile smart contracts. That's good. All right, so we got our setup. Let's go ahead and jump into our test. So I don't need this. I'm gonna try to do everything in my test files. All right, I don't need that crap. Don't need that. I will need ethers. Fire. And basically, I'm just getting stuff set up so that I can interact with the contracts. If you want to take a look at ethers.js, I highly suggest doing it. Throw this in chat. Yeah, so I mean, obviously, if you know Ether.js, you don't have to look through this. But for anyone who stumbles upon this video and they're just trying to learn, then I highly suggest you read through that. All right, so I'm gonna honestly delete all this stuff. I don't need none of it. Okay, so from scratch, let's go. All right, we're gonna do fallback. And what I want to do is I'm going to set it up so that I just recently learned this method. So basically when you're running tests, you want to make sure you have your tests run in a certain flow. So you have a before. How does your contract look before you have before you want to execute something. Then you have your execute, and then you're gonna have after. So like before, your contract should look like this. During, your contract is supposed to be doing something, and then after is what tests need to pass to make sure your application is functioning correctly. So this is like a journal software development testing strategy. And I just recently learned how to do this for Hardhat. So before I was using deploy scripts to try to commit hacks, but I think this way is way better. So let's go ahead and get this set up. We're going to have function. Up there. And we want to make sure we do a few things. So let's jump in Ethernaut. All right, so look carefully at the contract's code. You will beat this level if you claim ownership of the contract and you reduce its balance to 0. So these are the afters. When these test cases pass, that means you've successfully committed your hack. Things that might help: how to send Ether when interacting with the ABI, how to send Ether outside of the ABI, convert to and from weight units, and fallback methods. All right, so I'm just going to take this contract here. Let's go ahead and put that there. Let's call this fallback. All right, so one thing off the bat, I need to make sure that the programs match, because I won't be able to compile if I'm using a different program. So what's that? Got it. Okay. All right, so just taking a look through everything, just get familiar with the contract. If we want to look from like an auditor's eyes first, don't want floating programs. Mapping, address. Sender. All right, so we have a modifier to make sure someone can't call a specific message without being the owner. And they instantiate the owner here. They have a contribution, 1,000 ETH. Contribution message that sender is greater than contribution owner. Owner is equal to message sender. So you pretty much need to send more than the sender if you want to become the new owner. I don't have that much ETH, so we're not doing that. we're going to try to hack this to see if we can become the owner without sending this amount of money. And this thing is almost impossible because, yeah, the value has to be less than this. So essentially, they're making it impossible to become the owner. All right, so we can grab the contributions, and then we can also withdraw when we're the owner. All right, so this is an interesting function. This is the receive function, which basically means, look it up. If you send money to it without a message, you invoke that function. And actually, let's just use chat if we can use it. Let's receive. Yeah, so biggest thing is really the fallback function is now deprecated, but use it receive. So basically, if you send Ether to a contract without any data or function signature, you pretty much can invoke that receive function. So let's try and invoke this receive function to see if we can make ourselves the new owner. Now, I believe a key piece of this is that you need to already be a contributor. So the attack scenario will go like this. We can go into our test files. So in our attack, let's go ahead and set up our pseudocode, what we want to do. All right, so attack flow is this. First, we need to contribute to the fallback contract. And then second, we need to call the receive function, become the new owner. And then third, we need to call the withdraw function to withdraw all the ETH. All right, that's our attack flow. And then after, all right, so a few things we want to make sure is confirm that I, the attacker, is the new owner, or I am the new owner. Contract. Then we want to confirm that the contract balance is 0. So I'm gonna try to do this 2 ways. I may not get through all of them, but I want to do So I want to do one using an externally owned account first, so that I can learn how to use Ethers.js and just kind of like basically sending a transaction directly from my wallet. And then another way to do it is to create an attack contract so that the attack contract can perform the exploit for us. But let's do that first way first, which is using the externally owned account. All right, so there's a few things we need to do first. No, I didn't mean to do that. Submit instance, get new instance. Let's get new instance. All right, so player. All right, instance address. Wait, contract. Okay, this is the contract address of what we want to exploit. So let's grab this and let's go ahead and start our attack. So to set it up, we want to just a few things. I need a few global variables. I want a fallback contract. I want an owner. I think we're good with those for now. I think it's this one. We get contract at no. You didn't follow me, those right? This one. All right, so we want to get it at fallback. And then we also want to get the address, which is this. Okay. I'll say attacker equals await. Here's, I think that's it. Okay, let's first see if we can compile. All right, now let's test. What is this? Oh wait, did I say Fallout? Oh no, fallback. All right, fallback. Yes. For all set up for attack. For all hooks set up for attack. Get signers. All right. I think is maybe get signer. No, it's not. It's not that. No. So there's await ethers dot provider. Dot provider. Yeah. Okay. Get signer. Await ethers dot get signer. I'm using ethers. Is it dot provider? Here's dot get signer. Ethers and get signer. All right, so this should be it. We'll see. Nope. Get signers for all hooks out type price plate. Undefined get signer. Wait ethers dot get signers. All right, so we got through that debugging issue. I guess I had the wrong ethers imported. I thought that was the right one, but it's just this one. And the docs is what helped. And I believe I'm supposed to just name this fallback. All right, so essentially what we should get is my address. We should get my wallet address output to the console. Perfect. All right, so now we're connected. We have this contract data pulled down, and then I also have my wallet. So now I'm able to attempt to perform the exploit. So all right, so remember we have this contract, and now we have our ABI data for it. So let's go ahead and look at all the things we can call. We have like there's oh, so you say you're using the version of Hard plugin. Oh, so you like to use the Ethers.js version, the other one that was up. I can try to look at which other plugins. So you're saying like this one is the one that can be a little weird, but I think the one that I got from Patrick's was this one. Yeah, I can try to start using another one. All right, so we got this working. I think now we're going to see what can we call. So I'm going to try to call the owner of the contract. Oops. Original owner. All right, let's see if we can get this original owner, because the idea is we want to become the new owners. So we already know that this is my attacker address right here. And then now we want to see who the owner address is. Let's run that. All right, so this is who we're trying to remove as the owner and make me the new owner. Okay, so the first thing we need to do is just contribute to the contract. And remember, this is going to be just using it in an EOA, which is an externally owned account. So I'm just going to try to do this from my wallet address. And then in the next one, I'm going to learn a little bit about building Solidity programs and try to create an attacker contract. So let's do this. Let's contribute. Person who contributes to fallback. So oh, that's my Pomodoro timer. I'm good. I'm not tired, so skip it. Actually, let me change some settings. Get out of here. I want to change this to be. All right. So I usually try to do focus. So when I'm auditing, I like to do focus intervals of 30 to 35 minutes, but I'm thinking of someone respond. So Porter said he likes to join. He likes to pretty much work whenever he's feeling it, and then if not, he'll take a break. But I think I'm gonna try to do like an hour or maybe 45 minutes to an hour, and then have a break for like 5 or 10 minutes. But yeah, so when I'm auditing, typically it's like 35 minutes. But I think for this, um, I kind of get deep into the weeds of things, especially if I'm debugging, and I'll have to spend some more time. So I'll probably do 60 minutes on and sorry for that audio. Got some people going crazy outside. So 60 minutes on and then 10 minutes off. Yeah. Yeah. I agree. Okay. All right, so let's go ahead and hit this next Pomodoro. All right, so we are at the stage where we're building our. We're gonna just contribute to the wallet first because we need to be a contributor in order to attack this contract. So I have my fallback contract dot contribute, and I'm only contributing like a value of. Yeah, I think I'm only going to contribute this much. And actually, I want to see if and all this is doing, I believe, is just checking to make sure I have a confirmation for the transaction. Let's grab all right, so if we look at the contract, we have contributors, and what I could do is grab my contribution. So essentially, we need to check. We need to verify that we attacked. We sorry, not attacked it, but we need to verify that we actually sent a contribution. Contribution. Okay. So let's validate that we actually sent something to the contract. Read and contribute. What I do? Hmm. Contribute. All right. So let's see what I do wrong. All right. I sent a value of the right amount of ether. Undefined. Said looks like fallback contract is undefined for some odd reason. Oh, good catch. Thank you. So this is the perfect reason why I love this. Because like people who know what's going on can be like, hey, this is maybe a potential issue. So what I did was so we need to make sure we have some global variables so that we can actually invoke said contracts or said variables. And what I had accidentally did was reinitialize that variable, and now I couldn't invoke that. So um, we have our contract address, we have our fallback that's being used, we have our attacker that's being used, or is it being used? It's never read. Attacker, wait. All right. All right, so we got attacker being used. Okay, now let's rerun it and see. So I don't need this anymore. All right, now let's see if this works this time. Thanks, Robert. Nope, what we do? String argument. Oh, I think I need to convert this over by a big number. Invalid argument. So when I pass in a value, I can put in this. Let's see. Did I hit a limit? Okay. It's less than. So no, that's fine. True value to be less than this. Valid big. So let's look this up. So this is literally how smart contract hacking looks like. You're gonna run into a lot of issues, a lot of errors, but you have to be able to uh, read through things, look it up on Google, beginner, and see if you can find the answer. And then also just doing things like this. So having a stream where if anyone's ever watching and they see the issue, they can just call it out, and that's the benefits of working in a team and studying together. So let's see. That's remix. Hmm. Okay. Let me read this code again. Invalid argument version. So we calling. Not this one. So we're calling contribute. It's payable. So we're sending a value. Needs to be less than 0.001. Let's make sure. So let's make sure we're doing this correctly. So sending ETH. There we go. Try that. And we want 0.001. So I think it was converting everything incorrectly. I have to make sure we're sending the right amount. So we're going to send a small amount of Sepolia ETH. I have this much. So let's try to send this and let's see if we can become a contributor. So let's try that. It's getting hung up. Either that or let's see. Perfect. All right, so we made a contribution. So that means we are definitely able to commit this hack now because I'm now a contributor. So I can successfully pass this requirement. And then now I just have to call this fallback function, this receive function, with a value greater than this. And now we should be the sender. So let's go ahead and go through that attack real quick. So I'm a contributor. And I'll just keep this up. I mean, I really don't have to run it again because I'm already a contributor, but let me just take this out real quick. And then it goes back up here. All right. So we can call the receive function to become the new owner. So let's just look up. Actually, let me just try to figure out if that's the way. So transaction receive. We oh we're gonna have the two. So the contract we want to send it to is this fallback contract. I don't know if I have to do address, but let's look it up. No, that's not what I'm looking for. Yeah, I want the send transaction. Let's try chat. Yep. Nice. They give me the whole shebang. I need to send transaction, but that was informational. Uh, all right, here we go. This is what I'm looking for. So I want to send it to this address. I guess I had it reversed. So I want to send some money to this contract to invoke the receive function. And remember, to invoke that fallback, if you send money to a contract without a function definition or without some data, some call data, then you pretty much invoke that fallback function. So we have two in value. Let's switch this around. My keyboard is pooping out. All right. No. Let's just move this here. And I wonder if I should make that. What does this have to be? A string? Can we get that here? No. Yeah, we'll see. So let's try it with just this. I don't know if this actually, let me just put in address. Need this contract address here. Let's not shadow. Delete that shadowing. And then let's just call address. There we go. All right, let's see if we can become the new owner by sending this transaction. Oh, snap. Should have did was, let's actually get a receipt for this. Probably butcher the spelling. All right, so we're waiting for the confirmation. I should have print out the I should have print out this receipt, and then let's also print out the owner. All right, so all right, fingers crossed. I should be the new owner. This should correctly uh, exploit the contract. That's if I didn't mess up this call. And then what we're gonna do is we're gonna polish this up and make sure we have some nice tests to run to make sure the exploit was committed perfectly. All right, so this is the receipt. This is basically the transaction. Yeah, that's the value, gas price, gas used. Perfect. Perfect. And now I am the owner of this contract. So we did it. We successfully completed this challenge. Let's polish this up though, because we just want to make sure we're good hackers and we have some tests on our own side to make sure we've actually committed this exploit. Actually, no. I'm not done. So while we're the new owner, in order to pass this test or to successfully beat this challenge, we have to reduce the balance to 0. So that should be an easy one. This already has a withdraw function in place, so we can call this withdraw function. This only owner modifier will pass because we are now the new owners, and this balance will be 0. So let's go ahead and call that. So last steps, and we should be done. All right. Let transaction withdraw equals await attacker dot withdraw. No. All right. So what I want to do now is do some tests. So we're going to expect uh I don't know if that's already coming in as a string, but to be equal to the attacker. Actually, that's not a good way to do it because we already have the attacker and we already have new, new owner was await fallback contract dot owner. Because essentially the new owner should now be me. So that way I don't have to worry about calling this. I don't know what what type this is, but we'll figure it out. So we want the new owner to be equal to the attacker. And then we want how do you get balance? Ethers.provider.get balance. We want to get the balance of this fallback contract. Address or name, yeah. So we can go ahead and just say contract address. The idea is expect this balance. Ooh. All right, expect this balance to be honestly, I don't know if it's gonna take it as a string, but we'll see. I guess a good way is to do this console.log. New owner, and this should be me, my attacker account. Owner. All right. Well, now let's see if the balance is 0 and we can run off with the money. No. Owner is not defined. Oh. After. Okay. I probably don't even need all these, but all right, so we have a new owner. That should be good now. We're gonna say owner. Expect new owner to be attacker. Okay, let's try that again. All right, so farm exploited farm expected to be equal. Oh, there's a few things. Attacker withdraw is not a function. How is that possible? We were just doing that. Oh, Fallback contract, not attacker. All right. Perfect, perfect. Expect it to be equal to okay, so new owners and address. Attacker is not. Just do that right there. Attacker dot address. I may have to do a wait. I don't know if this is nested, if the address is already nested in this, but I'm gonna have to do an await to call that. All right. The balance is 0. The new owners. Okay, so that means we perform this exploit. Try not to delete something important. All right, so this is how the attack goes. I think this is a successful attack. We can check at the end, but so basically we are creating some global variables that we're going to use later on. Then we grab this attack, the address we want to attack. We start calling some functions on it. So first we need to contribute a balance to be able to become a contributor to basically satisfy this requirement right here. And then once we contribute some money to satisfy that requirement, we can trigger this fallback function, which is the point of this challenge. Basically, you have to send a contract money without a function definition or any call data, and you're able to trigger this fallback function. So we send in this balance. We already are a contributor, and now we become the new owner. And then once we become the new owner, we finish our attack off by withdrawing all the money in this contract. So if we take it from the top and run this exploit, it's no point in running this exploit over again. I mean, I'm already the owner and I've already withdrawn the balance, but basically I can still repeat this exploit by calling everything all at once, and yeah, everything should pass. And then we'll probably finish off this study session with this one today. But let's see what happens. All right. Our exploit was performed. Let's go to Ethernaut. Another way we can just confirm is, I don't want to do that. Let's submit the instance. Let's see what we got. Let's see if we successfully did the attack. All right, that's good. So we completed this fallback attack. You pretty much learned how to interact with smart contracts, interact with the fallback function, learned a little bit about mappings and how do you invoke some invoke some of the functions within the contracts. Yeah, and then we also learned how to debug some of the issues we ran into. So this is essentially how you would set up a test exploit. Obviously, don't take any of this knowledge and try to do bad stuff with it, but from here on out, we'll use this flow and the rest of these attack contracts, and it'll get progressively harder to do these. So this one only took, it looks like, about 2 hours to do, total of 2 of these, but in these next few, it probably will take a lot longer. So yeah, guys, I think that's it for today. I'm going to go ahead and cut the stream. But if y'all have any questions, just feel free to DM me, or here. Yeah, just DM me on Twitter if you have any questions, or put comments under the video, and I'll try to answer them. Alrighty, so we're good. I'll go ahead and cut out the stream. Some jams. Sorry if I blew your earbuds out.